Hello, we are all here. Carlos Treviño Ciar, are you here?
Yes, profe.
Okay. Okay, fine. Everybody's here. Uh, Today is the last lesson of the week, and today we will start with some news. I always like to start with a little news. Not always, but it's nice to do this. Then we're going to do very theoretical, an activity um, that reviews everything we have done so far. So it's not that dynamic, but I think it's a very good activity for you to have everything quickly together and to review if you understand everything. And then together, I want to do with you some exercises that come in the same document to make sure that you do well in the mini quiz. Okay, and then we end with the mini quiz today. In case we end this before the class is over, then I leave the rest of the time of the class for you to finish the great elephant census, um, which you have to hand in somewhere today as well. So I think you already saw the video. It's about this huge project that they're doing to count all the elephants on the continent, on the African continent, in order to know how many elephants are still there. The objective of this study or this experiment is basically to know how many elephants are still there. And based on the data that they are doing, then they can share this with governments and they can take preservation actions into place based on the data they have from the elephants. Okay, and it's a very interesting video. I hope you already seen it. If not, yeah, you have to do it. So let's start. The news of today is again news possibly that you say like, it's not really the news that I would look at, but like 1 or 2 days ago, it was published in Life Science that the Greenland ice is melting and it has passed a point of no return. So the island, Greenland is an island. It's bigger than Mexico. So Mexico is only about, like you can see here, it's only about 90% the size of Greenland. So Greenland is bigger than Mexico. And the interesting thing about Greenland that it's covered completely with ice. Okay, so here we have Mexico, and here is Greenland. Greenland is the biggest island in the world. It's an autonomous region of Denmark. So basically, Greenland has always been under control of Denmark here, but it's independent. The capital is Nuuk, somewhere here on the side. And there is very few people living in Greenland. You can already see on Google Earth that this part is already melting a lot. And Greenland is the biggest island in the world, and the ice on Greenland is between 2 and 3 kilometers thick. So think about that. It's like 2, 3 kilometers thick. If all this ice melts, which is happening right now, and even if we stop global warming right away, it will keep on melting. So if all the ice of Greenland melts, it will count for already 5 to 7 meters of sea level rise when it starts, but they don't really have the exact idea how much it will cause sea level rise, but it will go up several meters. Okay, because it's the second largest source of water on the planet. The biggest, where would it be?
Antarctica.
So it would be completely on the other side. It's Antarctica. We can talk about that later. I am very interested in Antarctica. I can talk to you about this a little bit later. There is even more ice on Antarctica, way more than on Greenland. But Greenland is definitely melting faster than Antarctica, and it's worrying a lot, because if it not only for the sea level rise, there's a lot of fresh water running into the ocean, and it's changing our climate. So you have here a pattern which we call the Gulf Stream. It's the hot air that comes from the Caribbean and it runs to Europe, and that's why Europe is so hot and Canada is so cold because it's all the hot air that, thanks to the spin of the Earth, reaches here. But if all the cold water is entering in the sea here, this current will be stopped, and it would cause that Europe goes into it can turn to be very, very cold again, and it could change climates and vegetation types all over the world. So if you want to consult this, please investigate a bit. It's very, very interesting what is happening in Greenland. Um, and yeah, nobody cares. This is worse. This about Greenland is way worse than coronavirus. It will affect the whole world, especially coastal areas. The climate will change. Desert areas will become green. Other places will become deserts. It's really gonna impact us a lot. Um, so now I want to go to the review. Okay. So I have a document here that I want to see with you all together. I would like you to participate. So let's do this together and to see that you understand everything we did until now. Okay. It's a nice document that really is a summary of everything. Okay. So what is science? Okay. Here we go. Science. Let me mark, is an organized way of gathering and analyzing evidence about the natural world. Okay. Who can give me another definition about science? What did we learn?
A way to explain natural phenomena and things we didn't understand many years ago.
Exactly. There you go. Its objective is give explanations for things that we don't understand. Okay. It only deals with the natural world, and this is also very important. Science is based on evidence and not on belief. Okay, that's why we have seen it so successful. That's why it's more successful than anything else um, that humanity has tried before. Okay, because we do experiments, we get the data, we get results, and we have proof. It's not I think it will be like this, I believe it's the fault of this. It's nothing to do with belief. The other thing that is very important about science is we always search for more evidence. Okay, think about what I said. I think that's a very striking difference with religion. Science admits that it's wrong. So whenever the explanation is not correct, they're not going to say, no, this is the proof, it has to be like that. No, they will investigate more and more. Science is dynamic, and it accepts when it's wrong, and it looks for more explanations like it says here. Okay. Then what is the scientific methodology? You can see it here in my background of today. Okay. So the first step is observation. Okay, you make an observation because you see no, I don't know. You see something in the natural world that you cannot explain, or you have a certain problem that you want to solve. Okay, that's the observation. You become aware of the fact that something has to be solved or something is unexplainable. Okay, from that observation you go to a hypothesis. Okay, who can tell me the difference between observation and hypothesis? What's the big difference between observation and hypothesis? Because
I know
yes,
that an observation is when you realize that something is out of place and you want to understand it more. And the hypothesis, thanks to the observation, you make a statement like, oh, this pen is red because of the solar rays impacted, stuff like that.
okay, very good, Emilio. Emilio says it almost completely correct. This is exactly what a hypothesis is about. But there is one more thing. It's not exactly written here, but there is something important about a hypothesis that in an observation you don't immediately have. So in an observation, you have a problem. In a hypothesis, you have a statement. Yeah, that's all correct. But what is the other thing about a hypothesis? What is the nature of the statement, let's say? What can you do with a hypothesis?
You can test it.
Exactly. You can test it. A hypothesis is a statement formulated in such a way that you can test it and you can measure things. Okay. And whenever you go test the hypothesis, okay, then you go to the experiment. Okay. And whenever you do an experiment, you have a controlled experiment. Experiments always have to be controlled. Think about what I told you about yesterday about the mosquitoes in Florida. I have my questions how controlled this experiment is, because if you cannot contain the experiment, you don't know what exactly will happen, you know? So that's what we mean with a controlled experiment, is that you define exactly the variables and that it stays in proportion, you know, that it doesn't go out of control. So in those experiments, we have variables, okay? And I'm gonna put them in pink because in fact, that's very important. We have the independent variable and the dependent variable, okay? Always remember together with this, because dependent, independent, it's not so clear for us than remembering that the independent one is the one that you manipulate, okay? And the dependent variable is the responding variable or the one that you measure. This is very important that you remember both things, because if you mix them up, everything is wrong, you know. In an experiment, we have very often a control group, okay? Because if you don't have a blank, let's say, you have to check against something else what the difference is in the experiment you're doing. Out of the experiment, you get the data, and out of the data, you can make conclusions, okay?
Mr. What was the control group?
The control group. The control group is the thing where you don't change the variable, okay? So think about the plant. You have two plants and you put them both in the sun, and one plant you give it water. So this is the one that you manipulate. That's the independent variable, the amount of water that you give. And in the control group, you don't give water to see what is the difference, you know?
Ah, okay, okay.
Yeah. Okay, so who can answer to me what is science? It's just up here. Who can says it in their own words? What is science? Vanessa, can you? Yeah, thanks, Emilio. But I'm gonna ask Vanessa because I would like everybody to participate. So can you give me a short definition of science?
It's science. It's like a experimental method
You just
of well, it's just to analyze things.
Okay, Vanessa, it's not so good yet. You should formulate it a little bit more complete. Carlos, yes, go ahead.
It's a way to explain things in a way more organized and gathering like experience about all the things you're surrounded, like all things.
Yeah. Yeah, I think it's okay that it's science is getting information in an organized way from the natural world to explain certain phenomena or something like that. That would be fine. You could also say, for instance, science is an organized way of gathering and analyzing evidence about the natural world. That would be also a good thing. So there's many, you can write several things here. What are the goals of science? Oliver? There are many goals, but just give me some.
Wait. Can you hear me?
Yeah.
Okay. Goals of science. Explaining the natural world in an organized way. Explaining natural phenomena that are beyond understanding with only common sense.
Yeah, it's okay. Yeah, science is definitely there to explain things. It's to improve things. So there is many goals here. You can find them a little bit here as well. So there is many goals of science. It's to improve our lives. It's improve the world that we live in. It's to explain things. There is so many goals about science. Okay, let's do an exercise. This is important, guys. I'm just doing this because if you get the correct answers, it means that you don't have to study anymore in the future. Then you know everything. So that's a good thing. So this is an exercise based on spontaneous generation, and pay attention because this is a theory that we will see next week. Okay, when we start with origin and characteristics of life, we will talk about it. So one of the theories of the origin of life is the one of spontaneous generation. Okay, spontaneous generation is a theory that was very popular in the 19th century when scientists or people, they believed that life would come out of nothing. Okay, so that all of a sudden life would come into existence out of nothing. Okay, so why did they think that? If you look to exercise 3, well, they were thinking that because especially when they looked at food, they would see that if they had a piece of meat or something, that just after a while there would be maggots. You know, maggots, those little yellow worms. There would be yellow worms in the meat. You know, we have all seen them when meat or food gets spoiled, that all of a sudden there is maggots in it. So people, they didn't have microscopes and they had no idea where did the little worms or the maggots come from. So they suggested that life would come out of nothing, that those worms would come in out of, they would come into existence out of nothing, okay? Because there is no parent organism, there was no father or mother, okay? What do you think a hypothesis would be when the scientists observed this? Who can give me a hypothesis when they made this observation? So they saw this situation and they couldn't explain it, okay? So that's the observation. Then they wanted to make a hypothesis. What would a hypothesis be here in when they saw that the life would come out of nothing?
Can
I know.
may I say it?
Yeah, go ahead, please.
Can life appear without? Can life suddenly appear out of nowhere? Like, would that be the hypothesis?
Yeah, that's a good thing. Could
Or
life come out of nothing when there is no visual connection to a parent? You should make it a little bit more complete, but I completely agree. It's a very good hypothesis. So the hypothesis is the statement or the question, is it possible that life comes out of nothing when there is no obvious mother or father organism ready? Okay, so this is a long time ago. In
sir, it can be like
yes.
Mister.
Mm-hmm.
It could be like life could come from microorganisms, also as a hypothesis or no?
Yeah, but yeah, it could be a good hypothesis, but the problem is that they didn't know that microorganism existed in those times. So yeah, I would accept it. Yes, is it possible
Okay.
that life can come from microorganisms? But I wrote here an hypothesis for you that is in fact a good hypothesis. Okay. And then in 1668, they did a different hypothesis, and they wanted to explain how the maggots appeared on food. Okay. The thing is that this Francesco Reveri, he saw that the maggots appeared on the food when there were flies around the food. Okay. So he thought maybe the maggots, they come from the flies, that the flies put eggs on the meat, and that's how the maggots appear. Okay, like you said, it's also possible that the maggots come from microorganisms, not only from flies, but they can also come from flies. So there's different kind of larvae. So he did an experiment. He had meat in a jar, he left it uncovered, and he saw there was maggots appearing. Okay, and then he did the meat covering, and he waited some days and he saw there were no maggots appearing. So what would be a conclusion from this experiment here?
That maggots come from the flies.
Yes, very good. Yeah, that's a conclusion indeed, because this is maggots. I can maybe put it nicer. Maggots form only when flies come in contact with the meat. Therefore, spontaneous generation of maggots does not occur. Okay, so this was in fact the first experiment that proved that spontaneous generation was not true. Of course, if you leave this meat in the jar covered and you wait a week or 2 weeks, the meat gets spoiled and there's maybe still maggots appearing, you know, but in the first days, it's like the maggots of the flies, okay? So this is already a very simple experiment. And somebody asked me, what is the control group? Well, the control group is you leave one jar uncovered and you leave the other jar is covered, okay? And then you can compare between the two to see what the difference is, okay? When we look at this experiment, what is the, let's go, I go there in a second. In this experiment here, what is the independent variable?
When the researcher puts a jar without the tap,
When you cover it,
another
that's
one,
dependent. That's
yeah,
what you
under cover.
Yeah, very good. The independent variable is the one you manipulate, and the thing that you manipulate here is the fact if you cover the jar or not. So here, this jar is uncovered, this one is covered. So that's our independent variable because that's what we manipulate. What do we measure, guys? What is the dependent variable? Camila?
The flies.
The flies, exactly. What we measure is, do flies appear or not? Okay, that's basically, not flies, maggots, in fact. Okay, that's the dependent variable because that's what we are going to observe. That's what we measure. Okay, very simple, right? Everybody got it? Okay, let's do one more exercise, still about spontaneous generation. So you see that every time they did a little bit more into depth the experiment. In number 3, it's a very simple experiment. In number 4, they already made it a bit more complicated. And then here in the 1700, Lazzaro Spallanzani, he did a different experiment to even know more about this. And here you can perfectly see how science all the time tries to improve and to improve and to improve and always search for more clear answers. So what it's about, let's say 30 years later, he did a different experiment also to prove that spontaneous generation is not true because life doesn't come from nothing. That's not possible, okay? But he proved that with a different experiment. What he did is he wanted to show with a different experiment that life did not arise spontaneously from food. So he already had his hypothesis, thinking that it's not possible that life comes out of nothing. So what he did was he inferred that some food spoils because of growing populations of microorganisms. This is what Emilio said. So it's not only flies, there's also microorganisms in the food. And that can you hear me?
Yes.
Yeah, I got disconnected. It's happening a lot this week, and I already called Telmex, and they're gonna check next week. So where were we? Here they're checking. So this person Lazzaro, he thought there was something more about it because even if the jar was covered, the meat would spoil. There would still come larvae or other life on the meat even when it was covered. So he went to another experiment and he saw that growing microorganisms, they didn't know about microorganisms yet, but it could be that life comes from something else and not only from flies, obviously.
Mr.
Yes?
Could you please share your screen?
Yeah,
or at least, yeah,
thank you. Forgot. Okay, so what did Spallanzani do? He complicated the experiment a little bit. So he boiled the meat, okay? He left the one bottle he left open and the other bottle he sealed, okay? So what did he see here? The sealed flask, there was no microorganisms appearing in the flask. And when he had the flask open, then microorganisms would appear. So what is here the independent variable?
When he sealed the flask and opened the flask.
So the independent one, that's the first one. What are we going to manipulate?
The meat.
Flask.
Boiling the meat.
Boiling.
No, the meat is boiled in both cases, okay?
The flask.
Yeah,
The
it's
seal.
what we do with the meat, okay? It's boiled, but we leave it open or closed. That's what we manipulate. We leave it exposed to air, let's say, okay? So what we manipulate is the meat itself. So what is the dependent variable, what we measure?
If there's flies after it's sealed or not sealed.
Yeah, not flies, but if there is microorganisms appearing or not, okay?
Yeah.
And now this is important because we haven't done this before. What are the controlled variables? Controlled variables are the variables that are the same in both conditions. Okay, what is here the controlled variable?
The boiling.
Yeah, we do the same boiling. Yes, what else is the same?
You have like the same type of flask, except one is
Exactly,
sealed
very
and the
good. The type of flask is also a controlled variable. If I would take a square flask and a round flask, it might change our results. It doesn't, but it could, you know? The same flask, yes. What else?
The water.
The water, yeah, that would be the same. It's the same piece of meat, let's say, the same water, yeah. Yeah, it's correct. It's good. The same water, and also another one is we boil it for the same time. So it's not indicated how much, but let's say if you do a good experiment, you have to boil both things for 5 minutes, let's say, or 10 minutes, or how long you want. Okay, that is the controlled variables. That's the ones that we keep the same in both conditions. Okay. Okay. So guys, there's more exercises, but I want to give you enough time to do this quiz. I saw that some of you already answered the questions, so I give you a second opportunity. But this is for everybody. But normally you cannot go ahead on this. But can you go into Canvas and do this small quiz? It's very short, guys. I'm going to give you like 10-15 minutes, but it's only 5 questions, I think. So let me show you. Go here and then go to scientific method and go to review questionnaire. So it's not an official quiz. This would be like a quiz already, but here it's just like a review questionnaire, like it's like a mini quiz. You click on it, and when you start, I cannot start because I made a quiz. You click start and you can do the answers. I gave you 2 attempts because I just saw that other students already did it. So everybody has 2 attempts. This is an exception. Normally you only have 1, okay? It's not that you're always gonna get 2 attempts. I just give you 2 attempts now because some of you already did it. And I saw that one person got like 15%, the other 0%. So I think there is a mistake there. So therefore I give everybody 2 attempts, not only to get a good score, but also to make sure that you understand how this works in Canvas, okay? You cannot go back to the question. So whenever you click an answer, you have to continue, okay? And then, yeah, give it a try, guys. You get 20 minutes, but I think 10 minutes would be more than enough.
Teacher, is in first partial, the quiz?
No, it's in module 1, week 1, like I just showed you. Yeah, it's partial 1. Yes, yes. Yeah, it's in partial 1, and then in week 2, scientific method, and then you go to review questionnaire. There you can find it.
Okay, thank you, teacher.
And that's what we will do for today. So do this quiz, and then after, when you're ready with the quiz, I'm not going to start with a new topic. I'm going to give you the time to finish the elephant census in case you didn't finish it yet. And in case you already finished, you can just disconnect and enjoy your weekend. If you, I know you still have classes, right? But anyway, I want to wish you a nice weekend because I will only see you until next week, Wednesday. Any questions about what we just did, or any questions about the content, what is science, or the scientific method? Because I can still answer some questions if you want.
I already finished, Miss.
If you're finished, you can do the great elephant census. If you didn't finish it yet, but you can disconnect.
Thank you. Have a nice weekend, Mister.
Yeah, you too. So the little girl you can see next to me is my daughter. She is 6 years.
Hola.
She loves science.
Hey.
And always when I'm teaching, she is not very far because she doesn't have classes yet, because she likes it a lot to learn about life and cells and everything.
Then she has a great teacher, doesn't she?
Yeah, I hope so. I don't know. You tell me later.
So, Mister, can we take the quiz 2 times or is only 1 time?
You can, if everybody gets 2 times, but I gave the option for 2 times because I saw some students that got a 0 because I guess they opened it and they didn't answer it and they lost it. So you can do it 2 times. It doesn't matter. The highest score will be saved.
Okay.
In case you
All
want
right,
to know score, you let me know and I change it.
Okay. Right. I finished. Have a good weekend.
You too, Santiago, and thanks for your participation. I really noticed that you are into science, and I like that you're so enthusiastic about it. Thank
No
you.
problem. No problem. Have a good weekend.
You
I
too.
finished too. Have a
I
great weekend.
finished.
Yeah, I finished too.
Guys, don't forget the elephant census. If you have time, you can do it right now. I will stay connected for the moment in case you have any questions.
Mm-hmm.
I turned it
You
in
want to do it
already.
later?
Teacher, I have
I
already
think
done that, and I already finished the quiz,
okay.
so I think I can leave now, right?
Okay,
Okay, so
perfect.
have a nice
just
Have a
weekend.
great week.
Enjoy it.
Teacher, have a nice weekend.
have a nice weekend. I just give you the option in case you want. I'm here.
Have a nice weekend.
You too. Take care.
Thank you, teacher.
You're welcome, dear.
I already finished. Thank you. Have a nice weekend.
Bye, Mister. Thank you.
Bye.
Have a nice weekend, teacher.
You're welcome. You too.
Goodbye, teacher.
Bye. Thank you.
Bye, teacher. Have a nice weekend.
Bye, teacher. Have a nice weekend.
Bye.
Bye.